Hello, hello. Welcome back. All right, so in this video, we're going to be going over section 6.2, which is about solving trig equations. And we've solved kind of on a minor scale using like the inverse trig functions. But we're going to kind of take it up a notch in this one. So for each of these, I'm going to show you just kind of like algebraically a little refresher on how we solve for these so that then we can apply that to our actual trig functions, okay? So if I asked you to solve something like this, 3u minus square root of 3 equals 0, right? What I'm asking you to do is to isolate the u, right? So the first thing I would do is move the square root of 3 to the other side, right? Which would give me 3u equals a positive square root of 3, right? Because when I move this over, I would move it by adding. And then I would divide off the 3, right? So divide both sides by 3, which means that u is equal to the square root of 3 over 3, right? So I kind of want to apply that same principle to this problem. So notice this problem is 3 tangent theta minus the square root of 3 is equal to 0, right? So the only difference between this problem and the one we just did is that instead of having a u, we have a tangent theta, right? But we can solve it the same way, right? I can go ahead and get tangent theta. This is what I want to isolate, okay? Because that's what we want to solve for so that we can figure out what that angle theta actually is. So we do it the same way. We move our square root of 3 over to the other side by adding. So that gives us 3 tangent theta is equal to the square root of 3. And then just like we did over here to get u by itself, we divided off the 3. Here to get tangent theta by itself, we just divide both sides by 3. So that tells me that tangent theta is equal to the square root of 3 over 3, right? So a good way to solve trig function equations here is if the tangent function bothers you here, or seeing a trig function within an equation bothers you, what you can do is you can do a u substitution, right? In other words, what you could do is you could just say, let u equal tangent theta, right? Then if I were to rewrite this equation, I would be able to write a u in place of tangent theta. So I would have 3u minus the square root of 3 equals 0, right? And then again, I would solve it. I've already solved this, right? And we know that u is equal to square root of 3 over 3. And then once we know what u is, then we could plug back in the tangent theta, right? So this would mean that tangent theta is equal to square root of 3 over 3. Now, for this class, I don't care. I don't care if you want to make the u substitution and solve it algebraically without worrying about all of the trig functions. That's totally fine. And then plug the trig function back in at the end. I'm okay with that. Or if the trig function doesn't bother you and you can just isolate it algebraically without doing a substitution, that's fine as well. Okay, I just wanted to show you both ways. And I'll do that throughout this lesson so that you can see and decide for yourself which method you like best. Okay, all right, so now that we've got our trig function isolated, now we need to figure out how to actually solve it so that we can find theta. Okay, so the first thing that I need to determine is where are my solutions going to lie. Okay, so we're talking about the tangent value of this angle theta has to be the square root of 3 over 3, right? So the first thing that I notice is that this tangent value is positive. Okay, if a tangent value is positive, we should be able to know which quadrant it lies in, right? So if I have a positive tangent, remember tangent we get by taking the sine value and dividing by the cosine value, right? It's that ratio. So in order to end up with a positive ratio, that means that my sine divided by my cosine has to be positive. So notice, if I start in quadrant 1, here my sine is positive and my cosine is positive, right? So positive divided by a positive, this is going to give me a positive tangent, right, in quadrant 1. if I look in quadrant 2, right, I have a negative cosine, but a positive sign. So since the signs are different, when I take that ratio, that's going to give me a negative tangent, right? In quadrant 3, I have a negative sine value, right, and a negative cosine value. So a negative over a negative gives me a positive tangent. And then in quadrant 4, I have a negative sine value, but a positive cosine value. So negative over positive, again, that's going to give me a negative tangent. So since I know that my tangent value of whatever this angle is, the tangent of it, ends up being a positive number, I know right now that it's not going to be in quadrant 2 or 4, right? Because those give me negative tangents. So that means that my solution has to be over here somewhere, right? Or it has to be down here in quadrant 3. So just by looking at this and seeing that it is a positive tangent value, we know that this is going to fall in quadrant 1 or quadrant 3. Okay, so let's go ahead and label our triangle. Now, notice here, square root of 3 over 3, this has already been rationalized, right? So I'm going to unrationalize it. So if we think back, what would we have had to have rationalized in order to end up with the square root of 3 over 3? Well, remember when we rationalize the denominator, we multiply on top and bottom by the radical we're trying to get rid of. So if I ended up with a radical or a root 3 on top, I must have multiplied by a root 3 on top, right? So what was my numerator before that if when I multiplied by square root of 3, I ended up with square root of 3, means my numerator would have had to have been a 1, right? And if I multiplied by square root of 3 on bottom and it resulted in a 3, that means I must have had a square root of 3 on bottom. Okay. If that's confusing, please, text me, email me, whatever, and I can go over that in more detail. But a good way to check yourself is once we have that tangent, think, okay, if I were to rationalize the denominator on top and bottom right here, I would multiply by square root of 3 over square root of 3, and that does in fact give me what I had before. Okay. All right, so now that we know what our actual tangent value was before we rationalize, we know that tangent is opposite over adjacent, right? So this means my opposite value is 1 and my adjacent value is square root of 3, right? So if I see a 1 and a square root of 3, I know this is either going to be a 30-degree triangle or a 60-degree triangle, right? Because on this one, it would be 1, 2 square root of 3, right? And remember, when the opposite side of my angle is a 1, that means that this is a 30-degree angle, okay? So we know that theta has to be 30 degrees. And then we check, because sometimes we may just want one answer, right? If we solve using a calculator, it may only give us one answer. But if we look at our instructions here, it says we want all theta that happens to fall in this interval from 0 to 360. So in one whole rotation, I want all of the answers that, satisfy what I have here. So this one just gives me this one, right? So I also need to figure out in this quadrant what my angle is. So because we know it's a 30-degree reference triangle, then we know this has to be 30 degrees as well, right? This time it would just be a -1 and a negative square root of 3, right? But either way, we can figure out what this angle is because we know that this line right here is 180 degrees, and then we're just going an additional 30 degrees. So if I do 180 degrees and I go 30 degrees past it to figure out what this angle is, I end up with 210 degrees. So that means my solutions for this one is that theta equals 30 or theta equals 210 degrees. Okay? So we've done this before, right? We've taken something like this where we know the trig function value and we've gone backwards to figure out what the angle is. So from here down, that's nothing new, right? We should be able to tell by the sign of our trig function value which quadrant it's in. and then what the actual angle is. The only new thing is that we have to do a little bit of algebraic work here in order to get the trig function isolated. Okay? All right, so let's look at another one. This one is the same one I just did. Why did I do that? Oh. Okay, so I want to show you the same one I just did, but I want to show you how to do it with your calculator and what to be aware of if we do it with a calculator, because we might run into some issues. Okay, so if I decide not to do a U substitution, if I decide I'm just going to solve this and leave the trig functions in there, I'm not going to worry about replacing anything with U. Okay, we already know how to do that. I'm going to work through it again. So first thing we do is move our square root of 3 to the other side. So that gives us 3 tangent theta is equal to the square root of 3. And then again, we divide off that 3. So we know that tangent theta is equal to square root of 3 over 3. Now, if I want to solve this using my calculator, I can go ahead and use tangent inverse, right? Because if I do the tangent inverse function on the left-hand side, then tangent and tangent inverse are going to cancel out, right? But if I do it on one side, I have to do it on the other side. So tangent inverse of square root of 3 over 3. So here those are going to cancel, and I end up with theta is equal to tangent inverse of square root of 3 over 3. Now, your calculator is set up in such a way that tangent inverse of theta is a function, okay? So what that means is that it's only going to produce one answer. Even if we have multiple answers, the way your calculator is set up is to ensure it's a function. So it's only going to give one output, right? So that it passes the vertical line test. So you are responsible for finding the other ones that lie within the interval they're asking you for. Okay, so let's go ahead and look at what we get when we type this into our calculator and how to type it into your calculator. For whatever reason, depending on what calculator you're using, it does not like it if you use the fraction button with this. Okay, so what I would do is we want to do the tangent inverse function. And remember, that is, let me see, how do I... Can't tell if that's more in focus or worse. But anyways, when you look for your trig function buttons, we have sine, cosine, and tangent, and then the second function on those is the inverse one, right? So I'm going to use my second button to get my tangent inverse, and then whenever you start typing this in, we're going to put in the square root of 3. Now, if your calculator is like mine, it puts parentheses to designate everything that's under the square root. So since the 3 is the only thing under the square root, make sure you close that. And then instead of using our fraction button, I'm just going to say divided by, and then put the 3 on the bottom, and then close the parenthesis. It's very important that you get all these parentheses closed, because this parenthesis here says that this little 3 is the only thing under that square root. Okay, and then these parentheses say that we're doing the tangent inverse of this whole mess. Okay, so when we hit enter, oh, I have mine in radians. Hold on. So here we want from 0 to 360, and it's in degrees. So make sure under the mode button of your calculator, you make sure that you have it in degrees. All right, sorry, let's do this again. So tangent inverse of the square root of 3. I'm going to close that parentheses, divided by 3, close that parentheses. Okay, here we go again, right? And we hit enter. And it gives us 30, right? Which we saw on the previous page that was one of our angles, okay? So when they say that, okay, theta is equal to 30 degrees, we have to make sure that we know that that is all of the answers we got. We have to check, okay? So what we know right now is that 30 degrees is a solution, okay? So what I would do is I would go back again. We're talking about tangent because tangent here is positive. We know that tangent values are only positive in quadrant 1 and quadrant 3, right? Because we get a positive over a positive, or we get a negative over a negative, which is positive. So it's our job to go ahead and draw in this other reference triangle and figure out what this angle is here. Okay, so again, I would have to take 180 and add 30 degrees to it to come up with a 210. So we would know theta is equal to 30 degrees or 210 degrees. So again, this is exactly what I got when I worked it out on the last page, but the only difference is if you use your calculator to solve for it versus drawing your reference triangles, it's only going to give you one answer. And if it only gives you one answer, you better go back and make sure on your unit circle that you have found all the answers corresponding to the interval they gave you for your solutions. Okay? Here's the other issue that you might have with calculators. So let's pretend just for a second. Okay, I'm going to put pretend. Pretend that our answer was negative instead, okay? So let's say you had something like tangent theta is equal to negative square root of 3 over 3. Okay, so I could solve this the same way. I could take the inverse tangent of both sides. Okay, so I'm going to work that out. But I want you to see here that anytime you know what the sign is of your trig function outcome, okay, so tangent here is giving me a negative. This being negative tells me what quadrants that this is going to be in, right? So a negative tangent means I had a ratio of a positive to a negative or a negative to a positive. And where does that happen? Well, if tangent was positive in these two, then quadrant 2 and quadrant 4 is where I would get negatives, right? So this means that it would have to fall in quadrant 2 or 4, okay? All right, so again, this is just another example I made up. It doesn't necessarily have anything to do with up here, but I just want to show you. So if we were to use our calculator for this one, again, we could take our tangent inverse function. If we take the tangent inverse of both sides, our tangent and tangent inverse is going to cancel. So we end up with theta is equal to tangent inverse of negative square root of 3 over 3. Okay, and again, we can go ahead and plug this into our calculator. So if I do tangent inverse, and I'm going to plug in a negative square root of 3. So I'm going to use my little negative button. Don't use a subtraction, use the little negative button. Okay, square root of 3, close the parentheses, divided by 3, close the parentheses. It tells me that that ends up being a negative 30 degrees. Okay, so when we get a negative 30 degrees, remember that tells us directional. That's telling us where this angle is located. Okay, if it says that we want to find all of the angles between 0 degrees and 360 degrees, okay, negative 30 does not fall in that one circle rotation, right? Because negative 30 degrees means that you're going this way 30 degrees, right? So once you have your answer, you have two jobs to do if you get a negative. One is to make sure that this is your only answer. You know, you have to check to see, is there any other answers out here? And then number two, you have to make sure that your answer is written within the interval that they have given you. So a negative 30, instead of writing it as a negative 30, right, I could write it as, we know that this is 360, and I could just go back 30 degrees. So if I subtract 30 degrees, that puts me at 330 degrees. Okay, 330 degrees. And that's the same angle, it's just written in a different way, right, with a positive angle instead of a negative angle. Okay, and then again, we know, because we had a negative tangent value, that we should have an answer in quadrant 2 and quadrant 4. So I'm going to go ahead and just copy this on over, right? Because we know that this is going to be a 30-degree reference triangle, right? So same thing on this one. We know this is 180 degrees, and we need to go back 30 degrees to get to this angle, right? because we need this angle and we need that angle. So to get this angle, it's 30 degrees short of 180. So we would just subtract our 30 degrees, which tells me that this is 150 degrees, right? So our two answers here would be 150 degrees and 330 degrees. Again, this was not the example given, but I just wanted to show you if you happen to have a negative, okay, it's quite possible that your calculator will give you a negative angle, right? And the negative angle needs to be written as a positive so that we know that we're going counterclockwise, right, on our unit circle so that it falls within the given interval of degree measures. Sorry, I'm losing my words. Okay. All right, so let's get off of this example. Let's look at a different one now that we kind of have the idea. Okay, so on this next one, I want to show you just a little review of algebra and then how it's going to relate to this one. Okay, if I wanted to solve this, if I was solving an algebraic expression and I see that I have two terms that have u in it, I would like to just combine those terms, right? But I can't here because this one also has a v and this one doesn't have a v. So they're not like terms, so I can't combine them. So the only way that I could solve for u in this case is to factor out that u as a greatest common factor. So if I take the u out, in the first term I would be left with just a v, right? And the second term, if I divide out the u, I'd be left with a 1. So that tells me that u times v plus 1 would take me back to this original equation, right? And then once I have something fully factored and it's equal to 0, the way that I solve is that I just set each factor equal to 0. So this would mean u equals 0 or v plus 1 equals 0. And then this one's already solved. This one I would then have to move the 1 over. So that would tell me that v equals -1, right? Okay, so that's my algebra review. So if that is like non-offensive to you and easier to work with, we can actually apply this to our trig function equation. Because notice what we have here is we have two different trig functions, right? So the first thing I want to do is I want to move it all to one side so that it's equal to 0. So I have cosine theta, cotangent theta. If I move this to the other side, I would do that by adding, right? So I would have plus cosine theta equals 0. So notice what I have here is I have a cosine within each term, but I can't just add them, right? Because this one has a cotangent and this one doesn't. So when I look at this, this looks very similar to that, right? I could let cosine equal u. Then this would be u, this would be u, and this would be v, right? So I could write this as uv plus u equals 0. And if I did that, then I could go up here and I've already solved it, right? Now, you don't have to do that. You don't have to do this substitution. I'm just showing you. Some people prefer to do a substitution so that they can focus on their algebra. Other people think that that just makes it harder, and so they'd rather just solve it the way it is. Okay, so if you want to do a substitution, this is how you would do it, and then you would just solve this equation right here. You would get these two answers, and then you would just plug back in. So u is 0. That means that cosine theta equals 0. V equals -1, so that would mean cotangent theta equals -1. Okay, so you can do it that way. That's how you would do it for substitution. Let me show you how you would do it if you don't want to use substitution. If you don't want to use substitution, we do it the same way that we did it algebraically. So I'm just going to rewrite it here. Is when I look at these two terms, I see that I can't add them because they're not like terms. So I go ahead and take out what they have in common, which in this case is a cosine theta. So just like I did when it was a u, I can factor out the cosine theta and write in parentheses what's left when I divide each term by cosine. So the first one's going to be left with cotangent theta. The second term, if I divide off a cosine, is going to be left with a 1. And now that I have it completely factored, I can just set each factor equal to 0. So this means that cosine theta equals 0 or cotangent theta plus 1 equals 0, right? Okay, so now let's see if we can solve and figure out what these angles are. Okay, on this first one, it says cosine theta equals 0. Now, we only get 0 as our angle for very specific examples, right? So if I were to draw my quadrants here, right, this is the point 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1, right? So cosine, remember, relates to our x. So we're looking for angles where the x value is 0. So here the x value is 1. Here the x value is 0. So that one works. Here the x value is negative 1. Here the x value is 0. So this one works, right? So I just want to double check and make sure I know what those angles are, since this is a nice quadrantal angle, right? This is our 90 degrees. So that happens at 90 degrees, and it also happens down here, right? So this is 90, 180, 270. So 270 degrees. Okay, so I'm done solving that one. I know what angles satisfy this piece. Now I need to solve and see what angles satisfy this piece. So for this one, I need to move my 1 to the other side. So I have cotangent theta equals negative 1. If I move it to the other side. Now, we're not used to dealing with cotangent, right? When we talk about the unit circle, usually we're dealing with sine, cosine, and tangent. So I would really prefer to write this in terms of tangent because that's something I'm more familiar with. So the way that tangent and cotangent are related is that they're reciprocals, right? So if I want to go from cotangent to tangent, I could rewrite this as negative 1 over 1, and then I could just do the reciprocal, right? If I do the reciprocal, I get 1 over negative 1, which is still negative 1, right? So that helps me a little bit. So first thing I notice is that my tangent value is negative. So if my tangent value is negative, that tells me which quadrants this angle should lie in, right? Remember, tangent I get as a ratio of sine to cosine. So if I want a negative, that means my sine and cosine values can't both be negative or can't both be positive. So where does that happen? That I get a positive and a negative would be over here, right? Where sine is positive and cosine is negative. So quadrant 2 or quadrant 4, right? Because down here I have a negative sine and a positive cosine. So quadrant 2 or quadrant 4, okay? So that means I have an angle down here that should work, and I have an angle up here that should work. So I just have to figure out what reference triangle I'm talking about, okay? Now, most of the time when we do tangent, we get wonky numbers, right? Because we're taking a fraction and dividing it by a fraction. There's only one reference triangle that has the same sine and cosine values, right? So that when I divide them, I get a 1 or a negative 1. And that's the 45-degree triangle, right? If this is a 45-degree triangle, remember a 45 degree was 1, 1 square root of 2. So 1, 1 square root of 2. And in this case, right, this is going to be a negative 1 because we're below the x-axis. And the same thing over here. This also has to be a 45-degree reference triangle. So this is going to be 1, 1 square root of 2. And this time my cosine or my x value is negative, right? So we know that these have 45-degree reference angles, but now we have to see what the actual angle is. So the first one is going from here to here, right? So this means that we're 45 degrees short of being at 180. So I'm going to go ahead and take 180 degrees, and I'm going to subtract 45 degrees because we're just short of coming all the way down to 180, right? So 180 minus 45 leaves me with 135 degrees. And then the same thing over here. We now need this angle, which goes from 0 all the way over here, right? And this angle is going to be 45 degrees short of making it all the way back to 360. So I'm going to do 360 degrees minus that 45 that I'm short of making it back to 360. And when I subtract, I get 315 degrees. Okay, so what we're doing is we're solving this equation. And when we solve this equation, the things that make it a true statement are the angles that cause the cosine to be 0, which is 90 degrees and 270, and also the angles where the cotangent ends up being -1, which we just figured out would be at 135 and 315. So for this specific problem, we have 4 answers that solve it. Okay, so all together, we're saying theta could be 90 degrees, it could be 135 degrees, it could be 270 degrees, or it could be 315 degrees. Okay, and I just wrote them in order from smallest to largest. Okay, but basically it could be these answers, or it could be these answers we just came up with. Okay. All right, so just a little bit different strategy. So the 2 that we've done so far, we've had our original interval for angles in degrees. So I want to show you same type of thing using algebra to solve, but maybe where we want our answer in radians versus degrees, okay, and what that looks like. So let's go over here at page 4. This one says u times u plus 2 equals 1. Now this is different from the other one we did, right? Because before we had a 0 over here. If you have a 0 over here, then you can just say, okay, u equals 0 or u plus 2 equals 0. But that only works if you have a 0. Here we have a 1. So we want it to be equal to 0 so that we can solve. So I'm going to go ahead and distribute this back in and move the 1 over, right? So when I distribute this back out, u times u is u squared. U times 2 is 2u. And then if I move this 1 back over to the other side, I do that by subtracting. Okay? And now I have, thought I had something on my foot. Now I have 3 terms, right? So with 3 terms, we could try sum product, right? Or our factoring method, whatever your factoring method is. So my factoring method is sum product. That's what we teach here at ENMU. If you use trial and error or whatever else, that's fine. But let's check and see if we can factor it first. So to factor it, I would need a sum of 2 because that's my middle term. And I would need a product or something that multiplies to my first coefficient times my last. So 1 times -1 is -1. So is it possible to find something that multiplies to -1 that combines to +2? And here it's not, right? Because the only thing I can multiply to get -1 is -1 and 1, right? And if I combine those, that gives me a 0, not a 2. So this is not possible to solve by factoring. So if we can't solve it by factoring, our only other method is to use the quadratic formula, right? Remember the good old quadratic formula? Because we have a u squared, right? So if our highest variable is to the 2nd power, that makes it a quadratic equation, which means we can use the quadratic formula. So I'm going to go ahead and just, excuse me, write it up here. So u is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you're super familiar with a quadratic formula. I know you may have not seen it in a while, but this is definitely something that just keeps popping up all along your mathematical career, okay? All right, so these a, b's, and c's are coming from the coefficients of our 3 terms here. So here our a is going to be 1, our b is going to be 2, and our c is going to be -1. So I'm going to go ahead and just plug in for our specific problem here. So this means that we have, I'm just going to write it over here. So this says to do -b, or the opposite of my b. My b is 2. So if I do the opposite of b, that would be -2. plus or minus the square root of b squared. So if I take my b, which is 2, and I square it, that's going to give me 4 minus 4 times my a, which is 1, times my c, which is negative 1, all over 2 times my a, which is 1, right? And then I just want to do some simplifying. So u is equal to, I have the negative 2 out here, plus or minus the square root. Now, under here, excuse me, when I multiply these three numbers together, I have a negative in front of the 4, and I have a negative 1. So negative times negative is going to make that a positive, right? And 4 times 1 times 1 is just 4. So I have the square root of 4 plus 4, all over on bottom 2 times 1 is 2. Okay, and I keep simplifying. So I can add the two numbers under the radical, so negative 2 plus or minus the square root of 8 all over 2. And then 8 is a radical we can actually simplify, right? It's not a perfect square, so it doesn't come out to just a nice pretty number, but we do want to simplify it. So let's go ahead and simplify. 8 is the same thing as 2 times 4, right? And 4 is 2 times 2. So I have 2 copies of a 2. That means I can bring the 2 out, right? That's like saying I have a 4, and the square root of 4 is 2. So the 2 is going to come out, and then I also have a 2 that's going to be left over. So I'm going to go ahead and rewrite this. So I have the negative 2 plus or minus the 2 that I brought out, and the 2 that's left over under the radical, right? And it's all over 2. Well, and now I can simplify even more, right? Because every single term has a 2. So if I reduce every single term by 2, that's going to give me negative 1 plus or minus the square root of 2, right? Okay, so quick little refresher on how to solve that algebraically. The same thing is true if we're trying to solve with trig functions, okay? So here we have cosine x times cosine x plus 2 is equal to 1. So I am going to solve this with a u substitution because, hello, I just figured out what u equals. So this would be the same as saying, let's let cosine x equal u, right? So what we just determined up here, right, is that u is equal to negative 1 plus or minus the square root of 2, okay? Now again, you could go ahead and distribute this out. If we hadn't already done all this mess, right? If you distribute it, you would get cosine squared plus 2 cosine minus 1, right? And here that would be a little bit more tricky on how to solve for cosine when you have a cosine squared. So for this one in particular, it might be easier to go ahead and write a u instead of cosine so that we can just solve it using the quadratic formula, right? All right. So here we now have our answer that we got from doing the quadratic formula. Now that we know what u equals, we need to plug back in what u originally represented, right? So this means that cosine x equals negative 1 plus or minus the square root, okay? And I'm going to put a note over here because I know if I don't write it down, y'all probably don't write it down. But what we're doing here is we're just saying let u equal cosine x. Because if we put a u in for cosine x, what we end up with is this equation, right? And then this equation, we just showed how to solve it. So if we let u go in for cosine x, we have this equation, which we just solved. So we end up with u equals negative 1 plus the square root of 2. And then all we have to do is plug back in for what we let u equal. Now that we know what u is, we can go ahead and say, okay, well, let's just let cosine x go back in for u. Okay, so now this is what we need to solve. Now, looking at this, we can look at this and realize pretty quickly this is like not a pretty angle, right? I've never seen a cosine value that looks like that. Not ideal, right? We're used to seeing cosine is 1/2. Cosine is negative square root of 2 over 3 or something like that, right? We're not used to seeing something like this. So what this tells me is this is not a friendly angle, meaning we're not going to get something like 30 degrees, 45 degrees, 60 degrees, 270 degrees, right? We're not going to get those nice pretty angles that we're used to dealing with. So this one's going to come out yucky. So I'm going to go ahead and write out my two options here because we have a plus or a minus, right? So this means we have cosine x is equal to -1 plus the square root of 2, or we have cosine x is equal to -1 minus the square root of 2, right? So we have two possible cases, right? So let's think about this. Remember, I have to figure out what quadrant these angles are going to fall into, right? So I do that based on their sign. So if I look at this, this is saying the cosine of this angle ends up being this. Now, I don't really care what that equals, but I do need to know if it's positive or negative so I know what quadrant we're dealing with. So if I do -1 plus the square root of 2, just to see in my calculator, that's a positive number, right? So I'm getting a positive number. So I need to figure out what quadrants do I get a positive cosine value in, okay? So if this is a positive number, that means that this is going to have to fall in what quadrant? So if I think about my unit circle, where is cosine positive? Well, cosine is relating to the x, right? So anything on this side of the y-axis gives me a positive x value, right? So that would be this quadrant or this quadrant. So quadrant 1 or quadrant 4, okay? So we know that our angle has to be here or our angle has to be here, right? So in other words, this angle or this angle, okay? And then I'll do the same thing for this case, right? All right, so let's go ahead and see if we can figure out what those angles are going to be now. So to solve, I'm going to use the cosine inverse function, okay? Cosine inverse. So I have cosine inverse of cosine x is equal to cosine inverse of -1 plus the square root of 2. Cosine and cosine inverse cancel. So I have x is equal to cosine inverse of -1 plus the square root of 2. Now, remember, on this one, let me just scroll back up for a hot second. Remember, on this one, this is the interval that they gave us, right? So what that tells me is that we are talking about radians. Okay, so make sure when you calculate this, your calculator is in radian mode to ensure that it is written in the way that our answer needs to be. Okay, so I'm going to go ahead and put my calculator here. I'm going to go back to mode, make sure it's in radians. Okay, hopefully by now you guys know how to change the mode on your specific calculator. All right, so now we can go ahead and do cosine inverse of -1 plus the square root of 2. And we're going to go ahead and hit enter. And this gives us an approximation, right? This says that our angle in radian measure is approximately 1.1437 blah, 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 right? I'm not going to write it all down, okay? So that's what this first angle is. This first angle is approximately 1.14 radian measures, right? So that's our first answer. Now we need to figure out what this other angle is, right? So the one that goes all the way around and ends up this short, right? So if I want to figure out, I know this distance is 1.14, and I know this distance, right, from here to here is 1.14, then I can find this other angle by taking my full rotation and just subtracting 1.14. Now, because we're in radians, we're going to consider a full rotation 2 pi, okay? So that means the answers that I'm going to get is the 1.14 radians and then whatever I get when I take 2 pi and subtract 1.14. Okay. And you probably want to leave all your decimal places on your calculator. Like don't round this one until after you've subtracted it from 2 pi. I went ahead and rounded this one just because I already have that answer. But whenever we do this, make sure you do 2 pi minus your last answer so that you have all the decimal places. So this comes out to 5.139, blah, blah, blah. So I'm going to say that this is approximately, this one's 1.14, and this one's approximately 5.14. 5.14. Okay. All right. So these radian measures solve the first part, right? Let me see if I can zoom out. I don't know how to zoom out. Awkward. Zooming out with a document camera. Okay, so remember we had two options here. We had where cosine x equals this positive number, and now we just determined when cosine x equals this positive number, these are the two radian measure angles that produce that cosine number. Okay, so now we want to do this other one. Okay, so this other one, I noticed right away, since I have a negative minus a negative, this is going to be a negative cosine value. So if I think about where cosine values are negative, it's where my x's are negative, which is on the left side of the y-axis, right? So this means that my angle would have to be over here, or my angle would have to be over here, right? This one would have to fall in quadrant 2 or quadrant 3. So let's go ahead and see if we can solve this one just like we solved the other part. So we're going to take cosine inverse of both sides. So if I take cosine inverse of both sides, cosine inverse of cosine x is equal to cosine inverse of -1 minus square root of 2. My cosine and cosine inverse on this side are going to cancel. So I have x is equal to cosine inverse of -1 minus the square root of 2. Okay, so let's plug that into our calculator and see what we get. Cosine inverse of -1 minus the square root of 2. Okay, so once I punch that in and hit enter, notice it says I have a domain error. A domain error means I am not allowed to plug whatever's inside here into my cosine inverse function. So let's go back and just think about it. Remember good old cosine was a cosine curve like this, right? And a cosine curve like this is between -1 and 1, right? So when we talk about the cosine inverse function, right, those numbers have to fall between -1 and 1. That's what I'm allowed to plug in to my inverse function. So if I went ahead and got a decimal approximation for this, right, -1 minus the square root of 2 is actually -2.4. -2.4. Okay, so what that is that it's a number that falls below that -1 to 1 interval, right? So it's not possible to do it. I'm just going to go ahead and say this is a value below -1, and cosine values are from -1 to 1. So for this one, there's no solution. Now, it's not no solution for the whole problem. It's just this piece didn't give us a solution, right? So the only solutions we get are from the first case where cosine x equaled -1 plus the square root of 2. Okay? All right, so this one was a little bit longer, a little bit more to think about, but the same process, right? We use our algebraic background to solve it. And then once it's solved, we can put back in our trig function values. And once we have our trig function values, just by seeing if they're positive or negative, we should know what intervals they fall into. And then from those intervals and using our calculator, we should be able to come up with the actual angle measure. Okay? I'm going to have y'all try this one, I think, because it's sort of similar. And it's a nicer one because you can solve it by factoring. So I'm going to talk about it just for a second, and then I'm going to pause it and let y'all work it out, okay? So on this one, I can already see, since I have a cosine, I'm going to skip this for a hot second. I have a cosine squared and a cosine. So this is not something that would be easy. I mean, I could factor a cosine out of each side, but then it's still not equal to 0. So I want to think about getting this equal to 0 first. So I would have 2 cosine squared x minus cosine x, and I'm just going to move this 1 to the other side by subtracting. Okay, so notice I have a squared term, I have a regular term, and then I have a constant term. So that should be kind of getting your wheels spinning for possibly something you could factor. So if you don't want to try to factor with trig function values, this is where I would just let u equal cosine x. So then cosine squared x would be u squared. Okay, so that's where we're getting this. I could write this as 2u squared minus u minus 1 equals 0, right? So that's where we're getting this piece. So if I were to solve this, it would be the same thing. So what I want y'all to do is go ahead and see if you can solve this, see if you can factor it. If you can't remember how to factor it, you can use quadratic formula, okay, whichever method you want. And once you get your answers from that, plug back in your trig function value, which should be cosine x, and see if you can solve it, okay? If you get stuck or you just have no idea, go ahead and play the video again and we'll go over it, okay? Okay, let's go ahead and talk through it. So this one is one that you can solve by factoring. Now, if you did it by the quadratic formula, that's fine. You should get the same answer. So when we look at our sum product chart, the pair of numbers that we can use to get a product of -2 and a sum of -1 would be -2 and 1. And if you took my college algebra class, you know we had the shortcut that anytime the leading coefficient is a 1, the numbers in your chart become the numbers in your factored quantities. But we can't use that shortcut here because notice our leading coefficient is not a 1. So we have to take the two numbers from our chart and replace this middle term with those two numbers. So that gives us 2u squared minus 2u plus u minus 1. And now we can factor by grouping. Okay, so if you need a little bit of a time to go over the factoring process, go ahead and pause the video. Make sure you understand that's kind of re-sparking something in your brain. If you use quadratic formula or if you factored using just a trial and error method, that's totally fine. Either way, this should have factored into u minus 1 times the quantity 2u plus 1. So we set each of those equal to 0 so we can solve, which we get u should be 1 or -1/2. Okay, so if you did quadratic formula, when you got your answer and you simplified it, it should come down to 1 and -1/2. If you didn't get 1 and -1/2, recheck your work. Okay, so now that we know that u equals 1 or u equals -1/2, we can plug back in what u originally was. So if you look at our original trig equation here, we were letting u be cosine x. So now that we know that u is 1 or -1/2, really what that's telling us is that cosine x is 1 or cosine x is -1/2, right? So those are the equations that we want to go ahead and solve. And I'm going to go ahead and focus on the first case, and then we'll look at the second case. So on the first case, cosine x equals +1. Well, anytime a cosine is a positive value, that means it's going to fall over here in quadrant 1 or 4, right, to get a positive cosine value. But the reason I didn't draw my little reference triangles here is because cosine is 1. And there's only one angle in this whole span from, quadrant 1 to quadrant 4 where cosine equals 1. And that's when x is 0, right? Now, this point right here, this angle, could be expressed as 0, it could be expressed as 360 degrees, it could be expressed as 2 pi. So make sure you know what your interval looks like. So our interval here is from 0 to 2 pi. So that tells us we want things written as radians. Okay, and notice there's a bracket on the 0 and a parenthesis on the 2 pi. So that means if I have something that happens to fall here, we're not going to express it as 2 pi, we're going to express it as 0. Okay, so x equals 0 is the angle measure that solves this piece. Now I need to see if I can find the angle measure that solves the second piece. So I'm going to move on to the second piece, and it says that the cosine of this angle equals -1/2. So if it's a negative cosine value, I know it has to fall within quadrant 2 or 3, right? Because on this side of the y-axis is where we get negative cosine values. And it's not, -1. So it's not going to be a quadrantal angle. So I'm going to go ahead and draw my reference triangles. And remember, cosine is adjacent over hypotenuse. So even though this is a negative, I know that my hypotenuse is always positive, which means the negative has to go with the 1 so that the 2 is my positive hypotenuse. So if I label -1 as my adjacent side and both of my hypotenuses here are going to be 2, well then if I fill in the other value of my reference triangle, we know that it's 1, 2, square root of 3. So that means that my opposite side has to be square root of 3. And this is either going to have to be a 30-degree triangle or a 60-degree triangle, right? It's not going to be a 45. So when the opposite side of my angle is square root of 3, that tells me it's a 60-degree triangle, okay? So a 60-degree triangle means we want the angle who has a reference angle in quadrant 2 of 60 degrees. So from here to here, which means we could take 180 degrees and we're 60 short of making it all the way to the 180-degree mark, which means that this is a 120-degree angle, right? Or it could be this angle down here, which is also a 60-degree triangle, but this time it's 60 degrees past 180. So I'm going to take this 180 mark, right? And then I'm going to add 60 to it to get down to this one. So when I add 60 to it, that gets me to 240. So right here, I have my answers. I know at 0, I have an answer. That's one of my angle measures. At 120 degrees and 240, right? But again, our interval, our open interval that they gave us here was radians. So we don't want to enter our answer as degrees. So you can use your calculator and convert it to radians, or we can go back to the old school way of doing it, right? Which is whatever our angle measure is in degrees, we multiply it by pi over 180. Here, 120 and 180 are both reducible by 60. So if I reduce both of those by 60, I end up with a 2 on top and a 3 on bottom. So this angle measure in radian degrees is 2 pi over 3. And then the same thing for 240. I'm going to multiply it by pi over 180 to get it into radian measure. 240 degrees and 180 degrees, again, are both reducible by 60 degrees. So when I reduce by 60, I'm left with a 4 on the top and a 3 on the bottom. So that radian measure is 4 pi over 3. Okay, so the 0 radians that I got from the first piece, and then the 2 pi over 3 and the 4 pi over 3 that I got from the second piece. Okay, everybody kind of okay? Okay, we have 2 more to go. I know this is a little bit longer video. Normally in my face-to-face class, I take 2 days to cover this one. But I felt like it was better to have a little bit longer video than an awkward video 1, video 2 on this one. So bear with me. We're going to do 2 more examples, and then y'all will be able to start on this homework. Okay, so same thing. Now notice this interval, we have switched back to degrees. So make sure your calculator, this is something I do before I even start the problem so I don't get a weird answer, make sure you put it back in degree mode. Okay, all right, so I have it in degrees and I want to solve this, which looks like tangent theta times tangent theta minus 2 equals 5. So what I'm going to do is I'm going to go ahead and just do my substitution so that I can solve it algebraically without all the trig functions in there. So I'm going to let u equal tangent theta. U equal tangent theta. So then what my equation will look like is, here I have tangent theta, so I'm going to call that u, times tangent theta, I'm going to call that u, minus 2 is equal to 5. And then I'm going to go ahead and distribute this out and move my 5 over so that it's equal to 0. So u times u is u squared. U times negative 2 is negative 2u. And then I'm going to move that 5 to the other side by subtracting. Minus 5 equals 0. So I see that I have a squared. So I want to try to see if I can factor it. And if I can't factor it, then I'll use quadratic formula. Or if you want to use quadratic formula from the get-go, you can if you're very familiar and comfortable with that. So let's try sum product. I'm going to try my sum would be negative 2, and my product would be negative 5. The only thing that I can multiply to get negative 5 is negative 5 and 1, or 5 and negative 1. And in either case, those do not combine to give me the negative 2 that I need. So it's not possible with factoring. So I'm going to go ahead and use the quadratic formula. And I'm going to write it out here just for those of you who don't have it memorized yet. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So looking at my equation, my a is going to be 1, my b is going to be negative 2, and my c is going to be negative 5. So I'm going to use those values to plug into my quadratic formula. So that says u is equal to the opposite of my b. So my b is negative 2, so I'm doing the opposite of negative 2 plus or minus the square root of my b squared. So my b is negative 2. If I square negative 2, I get positive 4. Minus 4 times my a, which is 1, times my c, which is negative 5. And this whole thing is over 2 times my a, which is 1. Okay. And then I'm going to go ahead and just simplify. So the opposite of a negative 2 is 2. Plus or minus the square root, I still have that 4. And then when I multiply negative 4, 1, and negative 5 together, that's going to give me a positive 20 all over 2. And keep simplifying. 2 plus or minus the square root of 24 all over 2. Now, the square root of 24 is not a perfect square, but it is a number that contains a perfect square factor, meaning if I take 24 and factor it down, I could factor it to 4 times 6, right? 4 is a perfect square. If I take the square root of 4, that comes out as a 2, right? And 6 is not. I could break that down to 2 times 3, but that's not giving me a perfect square. So the 6 is going to stay under the radical, and then the 4 I can bring out as a 2 because square root of 4 is 2. I'm going to go ahead and write. So what we end up with is the 2 plus or minus. I'm bringing out the 2. I'm left with the square root of 6. And it's all over 2. Right? And then notice every single term has a 2. So I can go ahead and reduce by 2, which tells me that u is equal to 1 plus or minus the square root of 6. Okay. So what we did is we replaced our trig function, tangent theta, with u so that we could solve for u algebraically. So now that we know what u equals, now we're just going to plug back in what u originally was. Okay, so this means that tangent theta equals 1 plus or minus the square root of 6. Okay, so that's what we need to solve for, and we want theta in degrees, okay, within 1 rotation of our unit circle. So I have a plus or a minus, which means I have 2 possible outcomes. So I'm going to go ahead and write them out. This means that tangent theta is equal to 1 plus the square root of 6, or tangent theta is equal to 1 minus the square root of 6. Okay. All right, so let's go ahead and figure out what we know about these. The first thing I need to know is whether my tangent is positive or negative. If I take 1 plus the square root of 6, this is going to end up being a positive number. right? And if it's positive, a positive tangent value falls within what quadrants? Right? Tangent is a ratio of sine and cosine, so it's only going to be positive when both sine and cosine are positive, or when sine and cosine are both negative, so that when I do a negative divided by negative, it's positive. So they're both positive in quadrant 1, and they're both negative down here in quadrant 3. Okay. Whoops. So that's where my angles lie. I'm going to have one here, and I'm going to have one here. So now I need to figure out what they are. So my calculator's already set into degrees. I can tell by looking at this, this is, you know, just not going to be a nice angle. It's not going to be one of our friendly angles, right? Because we've never seen the tangent value being 1 plus something. So I'm going to go ahead and use my calculator and do the tangent inverse. Okay, so that means theta is going to equal, if I do tangent inverse on the left-hand side, my tangent cancels, right? When I do tangent inverse on this side, I get tangent inverse of 1 plus the square root of 6. So I'm going to go ahead and punch that into my calculator. Tangent inverse of 1 plus the square root of 6. And it gives me 73.8, basically. All right, so we're going to say theta is approximately 73.8 degrees. So that means that this reference triangle, this is 73.8 degrees, right? But then I also need to know what this angle is. So the reference triangles are all going to be the same, right? They're all going to be 73.8 degrees. But this one is 73.8 degrees past 180. So I'm just going to take 180 and add 73.8 degrees. I'm just going to write it in parentheses. So my other angle is 180 plus 73.8 degrees. Okay, which means I get approximately 73.8 degrees. And if I take 73.8 degrees and add 180 to it for this angle that's just past 180, it's 253.8 degrees. 253.8 degrees. Okay, so these are the two angles that solve this first option, right, for our positive tangent value. Now I need to look at the second option and see what it is going to end up being. Okay, so first thing I need to know is this tangent value going to be positive or negative so that I know what quadrant we're in? And if you're not sure, you can always plug it into your calculator. 1 minus the square root of 6 ends up being a negative 1 point something something, right? So we know that this is going to be a negative value. And negative tangents come when our sine and cosine values have opposite signs, right? So like here we had positive is when both sine and cosine were positive or when both were negative. So if we want the negative intervals, now that's going to be these opposite quadrants, right? So that's going to be quadrant 2 and quadrant 4, right? Okay, if you're confused on how I'm figuring out these quadrants, please let me know. So now we just need to figure out what those angles, what those reference triangles are. Okay, so we can figure out our degrees. And again, I'm going to solve it by taking the inverse tangent function of both sides. So when I do inverse tangent on the left, I'll just be left with a theta. When I do inverse tangent on the right, I'll get inverse tangent of 1 minus the square root of 6. So I'm going to go ahead and plug that into my calculator. So inverse tangent of 1 minus the square root of 6. Make sure you close the parentheses on your square root and then close the parenthesis of the whole thing you're plugging into your inverse function. Okay. All right. And that gives me negative 55.39. Now that means going from here in this direction, I get 55.4 basically. right? Degrees. So our original instructions says we want it from 0 to 360 degrees. So we don't want negative angles. So I have to figure out what this angle is when I start on this side and go all the way around to here, right? So what that is 55.4 degrees short of being back up at 360, right? So I have, oh, here, I forgot to write it, negative 55.4 degrees. So in order to figure out this angle, I'm going to take 360 degrees and I'm going to subtract 55.4 degrees, right? And then I also need to figure out what this angle is. Now its reference triangle is also going to be 55.4 degrees, but what this one is it's 55.4 degrees short of being at 180 degrees, right? So if I take 180 degrees and I go back 55.4 degrees, that should put me at this angle. So my other answer is going to be 180 degrees minus 55.4. Okay, and then I just work those out. So 360 minus 55.4 gives me 304.6 degrees. And then 180 minus 55.4 gives me 124.6 degrees. So these are the 2-degree measures that satisfy the second tangent stipulation. So I have 4 answers for this one. Okay? All right. Last problem. So I want to show you one that's a little bit different because it has 2 separate trig function values in it, which could potentially cause some problems, but I believe in my heart you can handle it. So here we go. Let's look at this last one, number 7. All right. So number 7, notice right away I see that I have a cotangent value and I also have a cosecant value. Okay? Those are not the same. Those are not inverses. So already I'm thinking, okay, well, if I put u in for cotangent and v in for cosecant, then I would just have, u minus the square root of 3 equals v. That's not something I can solve, right, for u or v. So that substitution really doesn't help me out. So I want to think back, what do I know about cotangent and cosecant and how they're related? Well, like I said, they're not inverses. They're not reciprocals, right? The only way that cotangent and cosecant are related is in one of the Pythagorean identities. So I'm going to go ahead and just put over here, recall our 1 cocos, right? Our 1 cocos identity, which is that 1 plus cotangent squared theta is equal to cosecant squared theta. So it'd be really nice if I could rewrite this equation and only have one trig function in it, either cotangent or cosecant, right? But I can't substitute it in the way it is right now because this is just a regular cosecant and a regular cotangent, and this one has them squared. So I want to figure out what's the best course of action. I could take this identity and I could solve it for just cosecant, but I would have to take the square root, and then that's going to cause me a whole lot of mess of I don't know how to solve for a square root later, right? How do I get rid of that square root and solve for what's under it? So instead of taking my identity and taking the square root of it, I'm going to see if I can square these or get these to be squared terms. Okay, so I'm just going to take cotangent theta minus square root of 3 is equal to cosecant theta, and I'm just going to square both sides. So that doesn't affect my equality, because as long as I do to one side what I do to the other side, I maintain a true statement. So I'm going to take this and square it, and I'm going to take this and square it. Now, one thing to note is that when we square equations, sometimes that gives us extra solutions that otherwise we wouldn't have normally had. Okay, so I'm just going to write over here as a note, squaring can produce extra unneeded solutions. So what that means is that when we do that, we're going to have to check our answers. Okay. All right. When we square equations, sometimes that gives us additional answers that are not needed, that are not true, that are not correct. So once we get all of our answers, on a lot of these we ended up with like 4 answers. All we're going to do is check them. Like once we know what our angle is, like on the last one we said, oh, okay, well it's, I don't remember the last one. Here we go. So on this one we said, okay, well it's 73.8, it's 253.8, it's 304.6, it's 124.6. We could check all of those by just plugging them back into this. And we could take the tangent of the angle times the tangent of the angle minus 2 and see if it equals 5. So that's what we're going to have to do here is whatever answers we get, we're just going to check them back in the original equation to make sure they work. Okay? And it's really only a problem when we create extra answers by squaring. Okay? All right, so what does that mean to square both sides of the equation? Well, on this side, I have 2 terms. So I'm squaring a quantity. And when I square a quantity, that means I'm doing that quantity times itself. Cotangent theta minus square root of 3 is equal to. And over here, when I square just cosecant, right, I can write that as cosecant squared theta. Okay, so why did this help me? Why did I square this again? What was my point? What was I thinking? Okay, here's what I was thinking. I was thinking that if I could get a cosecant squared, then I could substitute in for that. Because we know that cosecant squared is equal to 1 plus cotangent squared theta. So now that I have a cosecant squared theta, I'm just going to take that out and replace it with 1 plus cotangent squared theta. Okay? So I'm just going to say plug in or replace, however you want to think of that. Okay. All right. On the left-hand side, though, we're going to have to multiply this out. So cotangent times cotangent is cotangent squared theta. Cotangent theta times negative square root of 3 is negative square root of 3 cotangent theta. So I'm done distributing that one. Now I need to distribute the negative root 3. Negative root 3 times cotangent theta is negative root 3 cotangent theta. And negative root 3 times negative root 3. Well, negative times negative makes it a positive. And square root of 3 times square root of 3 just becomes square root of 9, which is 3. Right? And then that's going to be equal to what I get when I replace this, which is 1 plus cotangent squared theta. Okay, sorry that's written super crooked. But now the good news is, even though it kind of looks bigger and messier, it all has cotangent. So that's good. That's good. We like having only one trig function. All right, so let's see what simplifying we could do. If I were to try to get everything on one side so that it's equal to 0, right? Because I see I have a squared term, so that makes me think maybe I'm going to have to factor. If I wanted to get my cotangent squared thetas on the same side, I would subtract this one over. But if I subtract cotangent squared from this side and I subtract it from this side, they actually cancel out, right? So I don't have a squared. So that's even better, because now that means I don't have to factor a 2-quadratic formula, and I got rid of 2 of my terms. So now let's see what I can do with what's left here. Well, these 2 terms are like terms. So if they're like terms, that means that I can combine them. So negative square root of 3 cotangent and negative square root of 3 cotangent, when I add those together, it just gives me negative 2 square root of 3 cotangent theta plus 3 equals 1. So since I only have one little trig function here, right, I can just isolate that. I can just solve for that trig function. So to solve for it, the first thing I want to do is get rid of this extra term. So I'm going to subtract 3 from both sides. So I have -2 square root of 3 cotangent theta is equal to -2. And then again, remember we're solving for cotangent theta. So to get it by itself, I now need to get rid of this -2 square root of 3. So I can just divide that off. -2 square root of 3 and -2 square root of 3. So when I divide that off, now I know that cotangent theta is equal to, well, a negative divided by a negative is a positive, and I can also reduce by 2. So that gives me 1 over the square root of 3. Okay, and this is good. We're making progress. Okay, so we were able to start with our original equation and dwindle it or whittle it all the way down to knowing the cotangent value. Now, if you want, you can flip it and turn this into tangent, but I'm not going to worry about that because since I have a 1 and a square root of 3, I feel pretty good about this either being a 30-degree reference triangle or a 60-degree reference triangle. So I think this is one that I can figure out, right? Because we know that cotangent is, let's see, what's tangent? Tangent is opposite over adjacent. So cotangent would be adjacent, right, over opposite. So I should be able to write or draw reference triangles for this, okay? All right, so let's think about this. We know that this is positive. This is a positive value. So cotangent is going to be positive in the same quadrants where tangent is positive, right? And tangent is when we get the ratio of positive sine and cosine or negative sine and negative cosine. So that means we're looking at quadrant, excuse me, 1 and quadrant 3, right? I'm going to go ahead and draw my quadrants over here. So quadrant 1 means we have this angle or we have this angle, right? Okay, so I'm going to go ahead and label my triangle so I can figure out what my angle is. My adjacent side is 1 and my opposite side is square root of 3, right? Which means that my hypotenuse has to be 2. And the angle that is opposite square root of 3 is a 60-degree angle, right? So this is a 60-degree angle, which means that this reference triangle is going to be a 60-degree angle as well, right? This is a 1. But the only difference is since I'm in quadrant 3, this is going to be a -1 and a negative square root of 3, right? Okay, so we know our reference angle is 60 degrees, so let's figure out what our two angles are. Excuse me, the first one is just 60. So theta is equal to 60 degrees, or, so that's this angle, right? But we also need to know what that angle is. So this angle is 60 degrees past 180. So if I take 180 degrees and I add 60 degrees to it, I end up with 240 degrees, right? So that means my angle theta is 60 degrees or 240 degrees. Okay. Now, because we have two potential issues. One is that I found my answers in degrees, and notice our original problem is asking for radian measures. So I need to go ahead and convert these to radian measures, which I can do by multiplying by pi over 180. So that's one thing. The other thing is I need to make sure I check my answers, right? When I check my answers, it will let me know if these are true answers or if these are just extra answers I got because I squared both sides of the equation. Okay. All right. So first, let's go ahead and change them into radians. So I'm going to take 60 degrees and I'm going to multiply by pi over 180. Excuse me. So I have theta is equal to, so here I can reduce by 60, right? 60 goes in one time, down here 60 goes in 3 times. So I end up with pi over 3. And then I need to do the same thing with 240 degrees. I'm going to multiply it by pi over 180. And both of these are reducible by, what, 60? So 60 goes into this 4 times, 60 goes into that 3 times, so I end up with 4 pi over 3. Okay. All right, so these are my 2 potential answers, but now I need to check. Okay, so I'm just going to put a line down here. Check solutions. All right, so let's check our first solution. Our first solution is pi over 3. So I'm going to go back up, excuse me, and look at my original equation. My original equation says cotangent theta minus square root of 3 equals cosecant theta. So I'm going to go ahead and write that down here at the bottom where I can see it. So cotangent, let me write over here, cotangent theta minus square root of 3 is equal to cosecant theta. Okay, so this should make a true statement if this is actually a solution. Okay, if it is, it'll make a true statement and we can circle it. If it's not, then it'll come up with a false statement and we'll have to throw it out. Okay, so let's check our first one, which is pi over 3. So we want to know if cotangent of pi over 3 minus the square root of 3, we want to know if that equals cosecant pi over 3. And you can use the chart that I had given you, or you can just use your reference triangle, right? We're talking about pi over 3, so that's this triangle. So cotangent of pi over 3. Cotangent is adjacent over opposite. So adjacent over opposite is 1 over the square root of 3. And we're going to subtract the square root of 3. Now this is like the square root of 3 over 1. So I'm going to go ahead and get a common denominator. Or in other words, I'm going to rationalize this denominator. So I end up with 1 over the square root of 3 minus 3 over the square root of 3. And when I combine those, I get negative 2 over the square root of 3. Okay? And we want to know, does that equal the cosecant of square root of 3? So cosecant is the inverse of, not the inverse, oh my gosh, the reciprocal of sine. Sine is opposite over hypotenuse. So if we flip that, it's hypotenuse over opposite. So hypotenuse is 2 over opposite, which is square root of 3. So are these two equal? And they're not, right? This is a negative 2 and this is a positive 2. So these are not equal, which tells me that this is not a solution, okay? Which is why I marked it out, okay? Not a solution. So now let's see if the other one is a solution, right? Because if I check this one and it's not a solution, then we have no solution to this equation. If I check it and it works, then 4 pi over 3 would be our only solution, okay? So let's check it. So now we want to check if cotangent 4 pi over 3 minus the square root of 3 is equal to cosecant 4 pi over 3. Okay, so just checking our answers. So let's look for cotangent 4 pi over 3. So now we're looking at this triangle, right? Cotangent is adjacent over opposite. So adjacent is negative 1 over the opposite. So negative 1 over negative square root of 3, right? Which is positive. Negative over negative gives me a positive. So positive 1 over square root of 3. Minus the square root of 3, which again, I need to rationalize this denominator so that these have the same denominators. So square root of 3, square root of 3 is going to give me a negative 3 over square root of 3, okay, right? Which gives me negative 2 over square root of 3. And I want to know, is that equal to cosecant 4 pi over here, okay? So cosecant is hypotenuse over opposite. So my hypotenuse here is 2. Yeah, 2 over the opposite, which is negative square root of 3. So is this a true statement? It is, right? It doesn't matter if I have the negative on the top or the negative on the bottom, or I could write the negative out front, right? negative 2 over square root of 3 is the same thing as 2 over negative square root of 3. So this one works out. Okay, that one checks out. So that means my only solution here is that theta is equal to 4 pi over 3. Okay. Now, the only reason we had to check it is because I squared both sides of the equation. If you don't square both sides of the equation, then we could easily, just say whatever answers we get are the answers we have. But here, squaring could produce additional solutions, which is what we saw. So we have to make sure we check our answers if we square an equation. Okay. All right. So that is the end of section 6.2. You should now be able to complete the corresponding assignment in my math lab. There's no worksheet for this section. If you have any questions, let me know. I'm happy to help.